This video is not sponsored by Bambu Lab. If you've been watching the channel for a while, you already know the setup here. 3D printing is the core of how I work, how I prototype, and how I build things. For the last year, my daily driver has been the Bambu Lab A1. It is an incredible printer. It's fast, it's reliable, and honestly, it completely raised the bar for what a modern bed slinger is expected to do. But I found myself hitting a physical wall with the form factor, because at the end of the day, it is still a bed slinger. The entire build plate has to move back and forth along the y-axis, and when you're printing low profile parts or standard decorative pieces, it is flawless. But the moment you start designing tall, dense, functional gear, that math shifting back and forth introduces structural risk. And if you want to move past standard PLA and tap into high temperature engineering filaments like PETG or TPU for actual functional use, a non-enclosed printer just isn't designed for it. You need thermal control, you need an enclosure. That is why I chose the Bambu Lab P1S for this video and for the next while that I'll be 3D printing for. So I finally made the choice to swap architectures and move to a Core XY machine. The geometry is entirely flipped. The build plate stays stationary on the X and Y axis, only lowering the Z axis, while a sleek designed toolhead handles all of the fast navigation using a fixed dual motor belt layout. On paper, it promises a highly controlled internal environment and massive acceleration advantages. But as someone who has been printing since 2021 and is already accustomed to a frictionless high-speed experience on the A1, is upgrading to a Core XY a genuine evolution for the workflow, or is it just diminishing returns? Let's break it down. When you look closely at a modern Core XY machine, the design language is incredibly satisfying. Instead of an open frame, everything is just contained inside a rigid structural enclosure. For an interaction of a product designer, this shift changes everything. Instead of just looking at an open gantry and screen, you're looking at a self-contained manufacturing station. The mechanical difference comes down to mass. In a traditional setup, one motor is dedicated to lugging around the heated print bed, while another motor is on the gantry and moves the print head. However, in a Core XY system, both stepper motors are permanently anchored to the back of the printer's frame. They use two continuous loops of belts to control the toolhead. When both motors turn clockwise, the toolhead moves along one diagonal. When they turn in opposite directions, it moves along a completely linear path. Because those heavy stepper motors never move, the toolhead itself can be stripped down to be as sleek as possible, riding on precision linear rails. Less moving mass means you can command much higher acceleration values. The printer's firmware uses input shaping to calculate the resonant vibration of that rigid frame, allowing the toolhead to make aggressive, instantaneous changes in direction without overshooting or creating ghosting lines on the surface texture. But the real reason I wanted the machine isn't just speed. It's the environmental control. The sealed glass enclosure traps the fumes and heat, stabilizing the temperature around the model. It completely redefines the physics of how the plastic layers bond together. To test this layout, I didn't want to run a generic benchmarking file. I wanted to design something that actively targets the structural vulnerability of a moving bed, creating something functional for my workspace at the same time. My desk has a specific problem right now. I have multiple camera batteries that are constantly scattered around, taking a valuable footprint. I jumped into my 3D modeling software to design a custom heavy-duty holder. But to make it a true challenge for the Core XY mechanics, I designed it with a narrow footprint but a wide horizontal profile featuring deep slots precisely cut for my camera's batteries. If you were to print a wide, longer object like this on a standard bed sling at high speeds, you would run into a warping problem. But luckily, this printer is not just cool because of its looks. It also has a functionality that may or may not have been super intentional. Because of the P1S's enclosed design, the heat from the nozzle and print bed act as a sort of heater for the air inside the printer, warping is no longer an issue. After I loaded the file into Bambu Studio and optimized the settings for the Core XY profile, I sent the print over to the printer in a nice looking black PETG filament to really give it a test. With the bed only moving upwards and downwards, the model itself remains completely static throughout the entire execution. Bambu Studio estimated the total print time at just under an hour, an incredibly quick pace for an object this wide and structural. I sent the file over, loading my filament to match the clean studio aesthetic, and initiated the print. The execution phase of the Core XY machine is completely amazing to watch. The toolhead moves with a level of precision and speed that feels highly mechanical and precise. The rapid directional changes are incredibly sharp, and the acoustic feedback from the stepper motors sounds perfectly tuned. But moving that fast comes with a trade-off in terms of physical energy. Even though the toolhead is lightweight, shifting direction instantly at those hyper-accelerated rates generates a massive amount of kinetic energy. Because the machine's internal frame is incredibly rigid and it doesn't flex, it means that the energy must have to transfer somewhere. It just goes straight down into whatever furniture the printer is sitting on. During the infill passes, I couldn't even feel the physical resonance running through my desk. My monitors had no slight vibrations, and you can't tell when the machine is tracking a complex pass by just the vibrations in the room. The print itself stays completely unaffected. The print finished exactly on schedule. I let the internal chamber temperature drop down naturally to prevent any rapid thermal shock. Pulled out the spring steel build plate, and with a slight flex, the holder cleanly came right off. So, if you're already using a highly capable machine like the Bambu Lab A1, is the transition to a Core XY printer actually worth it? If your printing workflow consists of entirely flat, low-profile models using standard PLA, then I say go for the Core XY, because you're probably experiencing quite a bit of warping with your printer. The Core XY machine that has an enclosure will completely eliminate that. It completely removes the physical limitations of a moving print bed, letting you focus entirely on the design itself. And we're to the point of this future in this technology where there are absolutely insane types of these printers. I'm talking perfect first layers straight out of the box type of insanity. And this machine, this Bambu Lab P1S, I think is one of those printers. Thank you for watching.